So variables. I think we've talked about variables, but if not, variables are unknown values. Usually we use x, and if you ever have a choice, try not to use O's, I's, L's, or E's. I think O, I, and L should be pretty self-explanatory. I's, I guess, that's because those are imaginary numbers, which we shouldn't see in this class. And E is Euler's constant, which, again, we may see Euler's constant later. So if you want to find out what Euler's constant is, Google it. Sometimes they represent many values, and that's why they're variables, because they can change. And like we saw with direct variations or joint variations or indirect variations, yeah, sometimes they'll change. And then, they could change proportionally or not, but as they change, the other value will change correspondingly in some way. And then using and defining variables is a key feature in problem solving. That's true, especially in word problems. And we solved problems last time, right, where it was like 3 consecutive integers, the sum of 3 consecutive integers is 66. It was important for us to define what x was when we did that. X was the smallest variable, because from that, then we can determine an equation based on just that information sometimes. Now, evaluating formulas, though, what they're going to do is they're going to give us some kind of formula, and yeah, usually they're based on something actual or otherwise. They're just based on something, but they're going to show that there's going to be variables in the formula, and then they'll give us values to replace those letters with. Okay, so you just go in there, whatever value it tells you, just replace all the letters with their corresponding numbers that they give us, and then evaluate from at that point, okay? There we go. This is a formula right there. This is not a problem. This is a formula for the surface area of objects. From what I remember, you do not have to memorize this. I believe they give this to you on the homework. If not, there it is. But this is an open box right here. So you may be wondering, well, a closed box would have 6 sides to it, like a cube, right? But this one is an open box, which is why there's 2 of these rectangles, but only 1 of this one right here. So they'll specify which one is length, which one is width, and which one is height. Again, we just go into this formula, and then we replace those letters with the corresponding numbers that they give us. So yeah, the surface area of an open box top, L is length, W is width, H is height. Not that we care. We just want the letters, and they tell us what the letters are, okay? And they kind of do that there at the bottom. The length here is 12, the width is 3, and then the height is 9. So we're going to take this formula. I guess I'll move it over here on the right. That gives us a little bit of space. And we are solving, in this case, for the area. So I replace there are some constants in this formula, by the way, right? The 2's. They're going to stay the same. But I know that the length here, that's my first L, I'm going to replace with 12. And then it's times the height, and the height in purple there is 9. So I'll multiply that by 9, and then add another 2 times the width, which is 3 there in red. And then multiply that by the height, which is still 9. And then add that to the length, which is 12. And then multiply that by the width, which is 3. Okay, now this gives us the entire formula, and you could solve this piecewise, every term individually. I'm very partial to the calculator, though, so that's what I'm going to do. Okay, I'm going to use the calculator. So let's go in here. 2 times 12 times 9 plus 2 times 3 times 9 plus 12 times 3. Enter. Boom, 306. So that's 306. Don't forget to label this one, at least if you're doing it by hand. This is the surface areas, and it's all in centimeters, so that's centimeters squared. Square centimeters, however you want to put that in there, is good. But that's 306 square centimeters. Now, to emphasize what I was saying earlier, right, you could have done, well, 12 times 9 is 108, times 2, that'd be 216, or then 2 times 3 is 6, times 9 is 54, and then 12 times 3 is 36, and then added those together if you wanted to. I don't know why you would, but you could. It always worries me when I hear math teachers like, you got to memorize this crap. And it's like, my phone knows it right away, but whatever. Yeah, I don't have control like that, okay? But, so it says the volume of a cylinder, that's V for volume, V of a cone, volume of a cone. Pi, by the way, is a constant. It's a irrational number because it's the decimal that goes on forever and ever and ever, as far as we know. And I feel it's weird that I have to specify that. But R is the radius of wherever you see the circle, and then h would be the height either of the cylinder or the cone. But you'll notice in this formula, this is just math nerd factoid, but the cylinder formula is in the cone formula right there. It's just divided by 3. I say this, not that I would expect anyone to do it, but if you go home and you make a cylinder and then you make a cone pretty much out of that cylinder, you could take the cone and fill it 3 times and then pour it into the cone. 3 times would fill the cylinder completely up. All right, the volume of a cylinder. Here we go, cylinder. There we go. And they gave us the formula right there. H is height, R is radius. Find the volume of a cylinder with radius 7 feet and a height of 20 feet. Now, it does say it around the nearest hundredth, and the reason why it says that is because usually in Math 950, just Math 950 or 920, they will use 3.14 as pi. But you'll notice on the calculator, 1 button to the left of 7 and then 2 buttons up there is the pi button. So I'm going to be using the pi button, all right? And here's our formula. So the volume equals pi times the radius to the power of 2 times the height. And they gave us the radius right here at 7 feet. So I'm going to replace my radius with 7. And then the height there at 20 feet. So there's replace h with 20. Well, you know what? I'm just going to put this in the calculator. And again, since I'm using the pi button, it may give me something that looks really nasty. Let's find out. Pi times 7 to the power of 2 times 20. Enter, see, look, it says 980 pi. That is an exact answer. Some of you may not have expected that, but it's the exact answer. We want the decimal, though, because it says to round to the nearest hundredth. Just push the double arrow button right above the enter button. Yeah, where my calculator? Oh, yeah, so 3,078. This is after pushing that double arrow button. And it says to round to the nearest hundredth. I got 0.760. Hey, zero's not too hard to round with. Just kind of get rid of it, make it a phantom 0. Last thing, of course, since I'm doing this by hand, just make sure we get this labeled. This is volume, so I'm going to make this in cubic feet. Here we go. The volume of a cone with the height h and radius r can be found using the formula. Find the volume of a cone with radius 9 feet and the height of 8 feet. Round this to the nearest hundredth. This formula is shown in 2 different ways. You just choose which one you like the best and then go from there. All right, so we'll use that one then. 1/3 times pi times the radius to the power of 2. Use a red for radius, and then h times the height there, okay? And they tell us here that the radius is 9 feet, so replace the r with 9. There we go, 9 right there. And then the height it says is 8 feet, so replace the h with 8. I'm putting those in parentheses. Yeah, like was asked, you could have just put multiplication between them. That should have been fine. Okay, but when I put this into the calculator, this will tell me the volume of a cone with these dimensions. And when I put that into the calculator, this is what I got, 678. Set to the nearest hundredth, so 0.584. But the 4 there is just going to keep the 8 and 8, and then the 4 becomes a phantom 0 right there. Don't forget your label on this, though. It's just feet cubed because it is volume now. Suppose that a cliff diver's height in feet after t seconds is given by this model. There's some physics involved there, but whatever. Find the height after 2.35 seconds. Well, look, they gave us the formula right there. So let's go and take this formula. In fact, I'll try to expand this here. I can write the t in. Okay, and it says the height after 2.35 seconds. That is a time right there. And t is time in this equation. Yeah, after t seconds. It says that right there. Just want to clarify. And so I'm going to go in here and I'm going to replace all the t's with about 2.35. It may look kind of ugly because of the way this is going to work. In fact, usually make it h of t, whatever. So let's go and replace the t's that we saw there with 2.35. Kind of narrow, just for space. 2.35 there as well. Well, this is something I can type directly into the calculator, which I would highly recommend. And again, just even showing that much work right there would be enough to get like full credit on an exam, okay? Because we do want the calculator to do most of the heavy lifting here. So negative 16 times 2.35, you can use the parentheses if you'd like, to the power of 2, but it's positive, so it won't make a difference. Plus 28 times 2.35, plus 49. Enter. Yeah, 26.44, that's height, and it was in feet. So let's put that in feet right there. All right, these are also known as literal equations. I don't really care what you call them, just we have to solve them, all right? However, the nice thing is that we're going to be using principles of equality. It's just going to be unusual because we're going to be operating with principles of equality on letters, and that's okay, because actually we've done it when we like subtract x from both sides. It's the same thing, it's just we won't be able to find like terms to combine, in which case we end with just an expression, which is okay, that's okay. Yeah, so it's just mostly variables that we're operating with, and this comes back to the idea of sometimes math is just what we want it to be. We want to force it to do what we want it to do, right? Like back in inverse variation, right? You'd get y equals k divided by x, okay? And you could say, well, look, I want to multiply both sides by x. You could, okay? And then you'd see that k equals xy, which it did. Okay, so that's just a manipulation of that specific equation to be what you want it to be, so that you would solve for k directly instead of having to use a principle of equality every time on the original equation y equals k divided by x. All right? So again, the answers to these are going to look weird for now until you get used to it. But, well, maybe you'll get used to it. I don't know. So here's some, well, the first one's kind of a common formula right there. That's the circumference of a circle. If you wanted to solve for r, here's what you do. So it's c for circumference equals 2 pi times the radius. Yeah, you're just going to divide both sides by 2 pi. Now I know these are technically numerical, but that would make that a phantom 1 right there. So, but it's a principle of equality, right? You divide both sides by 2 pi, and then you're left with the radius equals the circumference divided by 2 pi. And you have a formula now. If you had the circumference of a circle, you could then find the corresponding radius with this new formula that came from the circumference formula. All right, I'll do number 2, but I want to look at this third one because that is the formula for simple interest. Not that I think that's realistic, but right here, if it said to solve for r, you'd say, look, I'm going to divide both sides by p to make that a phantom 1. But you could also divide both sides by t to make that a phantom 1 as well. So you end up with r, which is the rate in simple interest, would be the interest divided by the principal times the time in the denominator right there, okay? So you can see, and well, I guess it's kind of the same principle of equality, just division between that first one and the third one. But this next one, you could solve for y. Now this equation right now, number 2, that's in what we call standard form for linear equations. So if you were to graph that, it would make a straight line. We're going to show this in its slope-intercept form, though, which, if you're not familiar with those, don't worry about it. We'll cover it, okay? By solving for y. So what I would do on this one, see it says to solve for y, so I don't want to add anything to it, so I'd have to subtract the 2x. So you could, I'm sorry, zero out the 2x. So you could say subtract 2x. Now I'm putting that underneath the 17. That will zero out, and you'll drop the 3y. But notice that the 17 and the negative 2x there are not like terms. So you can't combine them. You got to keep them separated. And just for technical purposes, I'm going to put the x value first so that it is in slope-intercept form, okay? And then the 17 was positive, so it shows as plus 17 right there. Again, they are not like terms to combine, so you can't say 17 minus 2x would be like 15x. You can't do that, right? 17 apples minus 2 oranges doesn't make 15 apples. See what I'm saying? So now you divide both sides by 3, and you can do it like this to get y equals negative 2x plus 17 over 3. That would work. Or you could write it separately, dividing both those terms by 3. So that'd be y equals negative 2/3 x. This is the way that we'll be looking at it later, plus 17 thirds. And with slope-intercept form, you'd get the slope and the y-intercept. Not that I think anyone cares or wants to know that, but eventually we will. The main point here is that I didn't want this as 2x plus 3y. Could I have even used that to solve for x? I could have. I would have subtracted 3y and then divided everything by 2. I could have done that, and then I would have been able to solve for an x value directly if that's what I wanted. So again, it is about what you want. I mean, it is about what it's asked for. But if you wanted to, if you ever saw an equation, you should be able to manipulate it yourself and do whatever it is that you want it to be. And I think that's a pretty nifty skill if you can get it down. So here we go. Solve this formula. It's just number 5. I don't know what happened to number 4, by the way. But solve the formula line equals math for n. Okay. Yeah, no problem on this one. So we want to solve for n right there. So it's just like the circumference formula, maybe the interest formula. I would divide both sides first by L to make that a phantom 1. And we're solving for n, right? So I divide both sides by I. Remember, I said not to use I, but there we go. So I divide both sides by I. And also Euler's constant, whatever, E. Oh. Yeah. Now, I'm of the opposite opinion. I think math is full of truth. But you don't have to. I mean, you're welcome to think whatever you want right there, okay? Yeah, math divided by lies equals n, whatever. I don't know. Solve this one for h, it looks like. Circle pi, I assume that's pizza. But h, right? So we're going to, again, just divide both sides by e. So that makes a phantom 1. Both sides, though. And then the a, so that's kind of a crappy a, but it works. And then the t as well. There we go. Boom. H. Now I see h equals, I'll make this kind of fast. I know the pi's in there too, but whatever. You guys want me to do this one? I know there's some sarcasm here because it's got bacon in it. What the heck, I'll do it. All right, solve for b. And yeah, sure, you could be aching for some bacon, but bacon for dinner equals yum. Yeah, I agree with that, but I got to subtract the for dinner right there. Maybe I should have just copied that because my handwriting, I think it's getting worse. Whatever. Yeah, got to do it to both sides to zero that out. Now, here we go. I'll use it. Bacon equals yum minus for dinner. See, that doesn't make any sense anymore. I don't feel too bad about that, though. So the last thing we got to do is divide both sides by some Aiken. There we go. You need to make those phantom 1s right there. So you just left with b, which is what we did want, and everything else right there. All right, solve this equation for f. Right. All right, we're going to solve for f on this one. You know what? You guys solve for f. Take 1 minute and try this one. Sounds good. All right, solving for f. So this, by the way, is its own term right there. So I'm not going to touch that one because I want to get that isolated, right? The f, whatever it's multiplied, I want to isolate that. Some of you may be thinking to distribute that f. Don't do it because right now we only have 1 f. If you distribute that, you're going to have 2, and that's going to complicate things. So the CA, I do not want to add that to this term, parentheses 3n minus 4 times f, right? So I'm going to zero that out by subtracting it from both sides. So let's go and subtract this CA from both sides. Now, I'm lining that up with the L more because I don't have any space on the left. But they are not like terms that I can combine right there. So I have to keep them separated. So that's an L minus CA, because we can't combine those. There's our equal sign. The CA's do zero out. Anything subtracted from itself is 0. And then we're just left with now, which is what the whole point was here, to start out with this positive 3n minus 4 quantity times f. You know what? I'll move this over so I have some space. There we go. I didn't really want to shrink it though. Okay? So now, look. The question now is, what is the coefficient of f? Because it is the coefficient because it's being multiplied by the f. Can you just divide by that whole coefficient? Yes, which is 3n minus 4. See that? So I'm going to do it. If I do it to one side, though, I got to do it to both sides. Could you put that in parentheses? Sure, you could. I'm not going to, but you could. There's a phantom 1. See how I crossed that out with the 1 right there? Phantom 1f. Boom. This solves this. It solves this equation for f, just like we wanted. There it is. So again, you may not have expected that because we're so used to seeing values come out as just one individual value. But now we have to get used to seeing, when we solve equations like this, come out with lots of letters in it, which is okay. That's perfectly fine. And it's doable because the principles of equality work not only with numbers, but with letters as well. Solve 5p minus 7w equals 14y minus 2 for p. So we are solving for p, and I notice that with the p's, all 5 of them, there's a minus 7w. We don't want anything added or subtracted. We want to isolate those p's. So I'm going to get rid of that negative 7w by adding 7w. But if I do it to one side, and notice I'm kind of purposely putting this off to the side there because there are no other w terms to combine that with on the right side of the equal sign, right? That will zero that out. I'm going to drop my 5p, which now equals, we didn't really touch the 14y minus 2 except to add that 7w to it, right? So yeah, we see no like terms to combine on the right. That's okay. But now in the end, just divide all the terms by 5, and we can just do that in one fell swoop right there, making that a phantom 1p equals everything that we have there on the right. Sorry, the 2 got kind of covered up, but that's a 2. Let's see if I can do that better. That's okay.